Hi everyone, this is part 2 of our video on how to write equations of polynomials. We started this last class. The difference is that today the equations we write will have what is called multiplicity. Okay, so to start we're going to define multiplicity. So multiplicity, as described right here, the multiplicity of a zero, remember a zero is a root or an x-intercept, is the number of times that its factor appears in the factored form of a polynomial. So it's the number of times its factor appears. So let's look at a couple examples. So in the first example, we have 4 different factors. Okay, so I'm going to go through the factors each time and talk about how many times they occur. So in the first one, this factor, we have to name the zeros and its multiplicity. So the zeros is determined by whatever this number is here, we make that opposite. So the 0 is 3, and its multiplicity, I'm going to abbreviate that M, is the number of times that this factor occurs. And we determine that by looking to see if there's an exponent on the factor, because an exponent means that it appears more than once, it's repeated. This doesn't have an exponent, but that doesn't mean it's not there, it doesn't mean it's 0, it means it is 1. So this has a multiplicity of 1. Okay, let's look at the next factor, x minus 2. That has a 0 of positive 2, and the multiplicity is how many times that factor right here occurs, and it occurs 2 times. It has a multiplicity of 2. Okay, let's look at this factor. This factor has a 0 of 6, and this factor right here has an exponent of 3. That means that it occurs 3 times. And then our last factor, this guy right here, x plus 4, has a multiplicity of 2. So remember, the 0 is negative 4, and it has a multiplicity of 2. All right, the last thing we're going to talk about with this example is the degree. So the degree is the highest exponent, but when a polynomial is written in factored form, it means that all of these factors and their multiplicities or their exponents, all the factors are multiplied, and when we multiply bases, their exponents are added. So to find the degree, we actually add all of the multiplicities. So if I add 1 plus 2 plus 3 plus 2, I should get degree 8. All right, let's look at the next example. So in the next example, I have 3 different factors. So I'm going to do them in different colors. So I have this factor, and this factor. Let's talk about their multiplicities and their zeros. So the first factor is just an x. Remember, if there's a factor of just an x, it's really like writing the factor x minus 0, right? We just don't write the minus 0. So that means that there is a factor, a 0 of 0, and the 0 has a multiplicity of 2. So 0 multiplicity 2. The next 0 is negative 2. And negative 2 has a multiplicity. Let's look at the exponent. There isn't one. That means that it's a 1. It has a multiplicity of 1. It appears 1 time. And then the last 0 is positive 5 because the factor is x minus 5. It does not have an exponent, which means it has a multiplicity of 1. All right, the degree of the function is all of those multiplicities added up. 2 plus 1 plus 1. So that's multiplicity of 4. I have one more example. I'm not going to do it for this video, but you might want to pause the video and try this example on your own to see if you can figure out the zeros and their multiplicities, and also the degree of that function. So next we're going to talk about what multiplicity actually tells us. So multiplicity tells us, I'm just going to read this sentence up here, how the graph of a polynomial behaves at a particular zero. The graph can either bounce off the axis. Sometimes we call a bounce a turning point, so it like changes direction at that zero, or it can cross through the axis. And we are going to categorize our multiplicities in two ways. They can either be odd, so odd number multiplicities, like 1, 3, 5, and 7. If we have an odd number multiplicity, that will cross through the x-axis, okay? If we have an even number multiplicity, so 2, 4, 6, 8, that would be an even number, they will bounce off the x-axis. Okay, so we're going to go to each of these graphs, and we're going to determine where the zeros are, if the graph is bouncing or crossing, and if that means there's an odd multiplicity or an even multiplicity. Let's look at the first example. So first example, here's a 0. If I look at what's happening at my graph at this point, the graph is crossing right through the x-axis. Okay, so at that 0, I'm going to put a C for cross, and that means, since cross, that means that my multiplicity is odd. So I'm just going to write the word odd. Let's go to the next 0. Here's the next 0. At that 0, my graph is crossing through the x-axis. So I'm going to put a C for cross. I have another odd multiplicity. Okay, the next 0. And let's look at why this one's different. If you study the graph at that point, do you see how the graph goes up towards the 0 and then bounces off and changes direction? It's kind of like a bouncy ball. It just bounces off the x-axis. So that's a bounce. And that means that at this 0, the multiplicity is even. And then lastly, this one. This crosses right through, so C for cross. That's odd. All right, let's do another graph and see if we can figure it out. So we'll look at the other graph that's right on our screen. This graph only has 2 zeros. I have one here and here. And the behavior at both of those zeros kind of looks the same. Crosses right through, crosses right through. Okay, so we have a cross. That means that this is odd multiplicity. And this is also a cross, or odd multiplicity. Okay. So the last one, you might want to pause the video and see if you can do this. There's a lot of zeros on this one, so I'm going to make this big. I'm just going to mark the zeros. Here's one, here's one, here's one, and here's one. So we have 4 different zeros. You might want to pause the video and think about, from left to right, are each of these zeros bouncing or crossing? And does that mean that they're even or odd? I'm going to go through the answers now, so hopefully you paused and tried to think about it on your own. The first one, this is bouncing off just like a bouncy ball. So this is a bounce, and that means that it's an even multiplicity. This is also a bounce. It doesn't go through the axis, so that's an even multiplicity. At this 0, it crosses through, so that's a C, so that's odd. And at this last 0, it's like a bouncy ball. It bounces off, so that's even. Next, we're going to put all this information together, and this is what we've been working towards. So last class, we talked about how to write an equation of a polynomial. we're going to do the same thing. So these directions here, 1 through 4, match what we did last class. The only difference is that now our graphs are going to have multiplicity, which means they're going to have exponents. So to do this, we're going to do the same thing we did last time, which is that we are going to use the x-intercepts and the multiplicity this time, that's the only difference, to write the factored form of the equation, and we're going to leave the a value alone. Okay, so let's look at the zeros. I have a 0 here. That's at -2. And that 0, let's pay attention to what's happening, is bouncing. That means that it has an even multiplicity. Let's look at the next 0 right here. That's at the number 5. That 0 is crossing right through the x-axis, so that's a cross. That means that it's odd multiplicity. Okay, so our equation only has 2 zeros. One has even multiplicity, one has odd multiplicity. So to set up our equation, we do f of x equals, remember that polynomials always start with that a value. We have 2 factors. So one factor, remember this value was -2. That means our factor is x plus 2. And since the multiplicity of this was even, when we go to put an exponent here, we can put any even number that we want. But to make your lives easier, it would be better to pick a small even number. And a small even number that is really often chosen here is the number 2. So I know that has even multiplicity. The next factor goes right after that. Remember, this was at, I can't see that number, but that's a 5. So that means my factor is x minus 5, opposite. And this has an odd multiplicity, which means I can choose any odd number. So I'm going to choose the easiest odd number I can think of, and that would be the number 1. And actually, you don't even have to write the 1. You could leave it blank because we know that if there's no exponent, it's automatically a 1. All right, so that's step 1. So we set up our polynomial, we set up our factored form with multiplicity. Step 2, identify another point and plug it in. And so there's always going to be a point easy to identify. I have one marked here. It's small, but I can see it right there. And that is the point 0, -10. 0 is my x, -10 is my y. I'm going to plug -10 in for f of x, because f of x is another way of saying y. So I get -10 equals a. I'm replacing x with 0. 0 plus 2 squared, 0 minus 5 to the first power. I can just leave that 1 off. Okay, -10 equals a. 0 plus 2, that's 2 squared. And 0 minus 5 is -5. -10 equals a. 2 squared is 4 times -5. And then lastly, I get -10 equals, let's multiply these two numbers. 4 times -5 is -20a. To solve for a, we have one more step, divide by -20. Okay, I get a equals, I'm going to reduce this fraction. I can divide by 10 to make those zeros go away. And since they're both negative, I get 1/2. So a is 1/2. So my final answer is to take my original function, my original polynomial equation, and rewrite it, but replace the a value with the number that we just found. So f of x equals 1/2 x plus 2 squared x minus 5. And you can put the 1 there, or you can leave it off. It doesn't matter. All right, we're going to try one more example, and then there's one for you to practice on your own. Okay, so for this example, let's look at the zeros. I have a 0 here at -2. That is bouncing. which means it's an even multiplicity. I have another 0 right here at 5. That is also bouncing, which means it's an even multiplicity. So we have 2 even multiplicities. So I write f of x equals a. My first factor is -2, so that would be a factor of x plus 2. Sorry, my first 0 is -2, so a factor of x plus 2. It's an even multiplicity, so I can choose any even number I want. I'm going to pick 2 because it's nice and easy. My next factor, or my next 0 is right here. That's 5, positive 5, so I'm going to write x minus 5. It is also an even multiplicity, so I'm going to choose another exponent of 2. The next thing I do is choose any point, so I'm going to pick this one that's marked right here, and that is the point 0, 80. 0 is x, 80 is y. I'm going to plug in 80 for y and 0 for x. Okay, and now I'm going to start solving. So I get 80 equals a. 0 plus 2 is 2 squared. 0 minus 5 is -5 squared. Next, I get 80 equals a. 2 squared is 4. -5 squared is +25. So I get 80 equals, let's multiply 4 and 25, that's 100. And write 100a. To solve for a, I divide both sides by 100. And I get a equals 80 over 100, let's reduce that. If I divide by 10, I would cross out one of the zeros, so it's 8/10. And I can reduce that further by dividing the top and the bottom by 2, and I get 4/5. If you wanted to write 4/5 as a decimal, you could. And in Delta Math and on an exam, you could write your a value as a decimal if you're more comfortable with that. I'm going to keep mine as a fraction. So I get f of x equals 4/5 x plus 2 squared x minus 5 squared. And again, that was just my original equation that I started with up here. But I just replaced my a value with the number that we found. Okay, so there's one more example you can try on your own. Good luck with that lab example if you try it. Here it is. All right, good luck.